Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shops. I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Today, we're going to talk about or continue our discussion we started last week on our component testing of EVAP systems. So this is part 2 of 2. So last week we talked about how the system operates and the base functions and why we need it and how we'll check leaks. And then also a little bit about the purge valve there. So we'll continue on this week with a little bit of a recap first. So first off, it is very important that we understand when we're diagnosing an EVAP problem on a car, we're probably going to get a code, but we want to be able to be sure that we understand what kind of code we're looking at. Yes, it's an EVAP code, but is it a leak related code or is it an electrically related code? Because some folks, they just see the word EVAP, they're like, oh man, it must be a leak. I got to go figure that out. But I think you'd agree, if we think about it, that diagnosing a leak is a lot different than diagnosing an electrical problem, right? It's a totally different strategy you need to use depending on if it's an actual leak in the system or if it's an electrical problem like a high or low voltage or a resistance issue. So you need to read through the whole definition of the code to start. And then if you need any more information, get a little bit more information before you start down whatever path you're going to start. So we talked about leaks a bit last time, how we would go through diagnose the leak using EVAP machine and the different sizes of the leaks, right? So we could have a small leak, very small leak, etc. So this week we're going to focus on mainly on the electrical side of things, the different switches and sensors and components of the system. So let's talk about our different EVAP components that we have in our EVAP system. So we have the purge solenoid. We talked a bit about that last time. And then we also have the vent valve, which is the other side of the equation. So the purge solenoid is the one closest to the engine. We'll call that maybe the front door. And then the vent valve, that's out the back. And that allows fresh air in and out of the canister. So that'd be like the back door. Then we have the canister itself, which has activated charcoal inside to absorb your evaporative emissions. We have the fuel tank pressure sensor, which is used to help us both check for leaks and make sure we're not in an overpressure or over vacuum type situation. And then, of course, on modern cars, fairly recent cars, the last 10, 15 years or so, there's miscellaneous pumps and associated modules on those vehicles now. So you may have heard of maybe Chrysler's NVLD system, which stands for Natural Vacuum Leak Detection, eSIM, which is the EVAP System Integrity Module, BMW has DMTL, which is Diagnostic Module for Tank Leakage, et cetera, et cetera. Toyota has them, Subaru has them, Nissan has them. Lots of different manufacturers are using leak detection pumps, vacuum pumps, that sort of thing, other associated modules that have sensors in them to allow to check for leaks, because EVAP leaks are, well, they're a common problem, but the manufacturers are also trying very hard to keep that to a minimum, the leaks and the problems. So they really want to be able to figure out if there's a leak, quickly figure out if there is a leak. So first, let's recap real quick on the purge solenoid. So this is our diagram of a basic EVAP system, right? So we have our fuel tank over here on the right-hand side. The fuel's in there. Got our check valve. Got our filler neck. We'll vent off the filler neck. Got our tank pressure sensor. Goes out. The EVAP vapors go into the canister. On the canister, we have the vent valve, and then we have the purge line that goes to the purge solenoid, which then allows those vapors to be sucked into the engine and then reburned. And that's how we're going to get rid of the vapors that are collected inside the canister, right? So we have the purge solenoid right there, as we said, maybe like our front door if we want to think about it like that. Generally speaking, purge solenoid it is a solenoid. It's usually a pulse width modulation control. So that means it's on time versus it's off time, right? So it's pulse width. How long is that pulse on as a percentage of on time? Oftentimes, the purge solenoids can also be controlled at a percentage of opening, right? So maybe it's 20% open, 30% open, all the way up to 60, 100% open. And then that will vary the pulse width, right? So if I have a 60% pulse, then I have a 60% opening, right? A lot of times it equates 1-to-1. But that allows the EVAP vapors go into the engine. So it'll, by using the engine's vacuum, it'll suck those vapors out of the canister and allows them to be reburned. Also, it is used for leak testing, right? So we'll draw a small vacuum oftentimes on the system. Then we close the purge and we close the vent, and that creates a sealed system. And then the computer can use the pressure from the fuel tank pressure sensor to measure whether or not we actually have a leak in the system. So we can use that both with our just using vacuum, or we can use it with one of those leak detection pumps, which we're going to talk about in a few minutes. All right, so that's the purge solenoid. That's that front door we talked about. How about the other side? So that's that vent solenoid down here. So a vent solenoid allows either air to escape from the canister, right? So we have our vapors going into the canister, and what's in the canister before there's vapors? Well, there's going to be fresh air, right? So that has to be able to escape. Or when we're going to purge the canister and reburn it, we need to open the back door and allow that fresh air in to displace the EVAP fumes, right? So it needs to be able to displace each other. Now, the vent solenoid is fairly simple in design. It's an electronic solenoid. Usually it's just on or off. So if I was going to test this, it'd be maybe a 12 volt and a ground, right? It's a pretty simple system, not a lot involved in it. And that allows, as I said, the fresh air into the canister when we're performing that vacuum, when we're purging, and also used for leak testing as well, in order to close off the back of that system. So also, as we're going to mention a little bit later on, is it also may be part of the canister nowadays too. On these more modern designs that they're using, these more modern systems, you can't replace it separate. You can't test it separate. It's part of the canister itself. So the vent valve is used for, as we said, with the purge to allow fresh air in. But it's also when I fill up the gas tank, I need to let that fresh air that's in the canister out. So you may have noticed fueling a vehicle before, or maybe you had a customer with this complaint out there before that, hey, you know, I go to pump and it pumps for like half a second, then it clicks off, or pumps for a second, then it clicks off. And I can keep doing that. But I know I have a pretty empty tank. It's like the tank is full, is how it operates. I know I got an empty tank, so why can't I fill my tank? Well, few cars have had this problem. Mazda, it got so bad where they actually issued a recall on it as well. So the deal with this recall is on certain Mazda 6 vehicles, and it affects other vehicles as well. It's just this is where this recall is from. On certain Mazda 6 vehicles, a certain type of spider may weave a web in the EVAP canister vent line, and this may cause a restriction in the line. If this occurs, the fuel tank pressure may become excessively negative, so too much vacuum in the system, when the emission control system works to purge the vapors from the canister. So as the canister is purged repeatedly during normal operation, the stress on the fuel tank may eventually result in a crack. So if I'm pulling excessive vacuum and not really releasing it enough, eventually that could crack the fuel tank, potentially leading to fuel leakage and an increased risk of fire. Now, that's obviously a bad thing. We don't want that to happen. So they issued a recall on it. And it's this golden orb weaver spider that causes this problem. And it's not just, it doesn't just like Mazda's really well, right? So I saw this a lot at the dealership at Subaru. But for the complaint that I talked about earlier, where, man, I cannot fill my tank whatsoever. And I would be willing to bet if you had one of these Mazdas with this problem, they would also complain that they can't fill their tank, but this is what they recalled it for in case the fuel tank crack, which is the other side of it. So if we look on the left-hand side, this would be like the vent, where the vent goes out into the atmosphere, right? Because it has to allow fresh air and fresh air out. It looks like, if you didn't see the one on the right, but if you were looking at the one on the left, it looks like, no, maybe it's just molded that way. Maybe that's just the white plastic that's over it. In real life, it looks kind of like a cotton ball. All right, so you're gonna have this thick web that doesn't really allow the air to flow very well, because it doesn't flow all that much anyway. It's not under that high of pressure. So it's pretty easy to fix, right? You take the vent elbow or whatever it happens to be out, and yep, there's a spider web in there, and a little compressed air, and it blows it out. Sometimes the spider comes out with it. You just got to be careful with that. You don't want to point it at you when that happens. Get the spider out of there, or maybe, use a screwdriver or whatever, just to get that, break up the web. And then once you do that, normal operation can resume on the vehicle. But that was just kind of an interesting thing that happens with vent valves, right? So it needs to be able to vent to the atmosphere. So I need to be able to fill my tank. Now, there's other reasons we might not be able to fill the tank too. Maybe the vent valve itself is stuck in the off position, or maybe I've seen it on some Chevys. They had a similar problem, but it wasn't a spider. It was just debris would get up in there on some Chevy trucks. Some debris would get in there and clog that vent line. And then they had plastic fuel tanks, and it would collapse the plastic fuel tanks sometimes as well. All right. So yeah, I see that Miata Mag. It says they just kind of have it hanging out on a wheel hub. Maybe it's just a good place to hang it to take a picture. I don't really know. I don't know why that's right there. I think that's just for the picture though. So yeah, it's just kind of that's fairly common. These spiders are everywhere in North America. It's not like it's just one part of the country or anything. And I don't know why in the world they really like this EVAP vent smell. It must be, and that's just where they want to hang out. That's where they want to build their nest. And there's dozens, at least, that I know of personally that I've dealt with them. There's got to be hundreds, if not even thousands, across the country, because it's bad enough for Mazda to do a recall, right? So it's fairly commonplace out there. If you ever run into that problem, that might save you a ton of time diagnosing in the future if you've never seen that before. So that's just another kind of just an interesting little tidbit that we run into out there, right? Who would have thought a spider, right? Spiders and rodents and all sorts of other things can screw up our diagnostic lives, right? All right, so we talked about the purge, the vent, and now let's talk about the canister itself, right? So canister, not all that fancy, collects EVAP vapors. That's its whole purpose in life, is to collect the vapors, has activated charcoal in there to help absorb some of those vapors. It may also, though, nowadays contain electrical components. So for example, this is one off of Ford, and if we look, we can see there is an electrical connector right there. It's a 2-wire connector. We see it comes with the bracket. And then we have this, they call it on this vehicle, it's a vent filter. That's the vent valve on the vehicle. So if this vent valve fails, guess what? We get to replace the entire canister because it's not available separate, at least in the aftermarket. Maybe at the dealership it might be, but aftermarket is not available separate. So you have to buy it as a whole assembly with the canister and everything like that. So that could be a pricey, just for a vent valve, could get a little pricey there. So just be aware of that. It's got a big old metal shield around it too, to keep it from getting hurt. Right? All right, so that was the that's this side. Let's talk about the fuel tank pressure sensor now. So this is a fairly simple 3-wire sensor. It measures the fuel tank pressure or vacuum, right? Because we could have a pull on a vacuum. It outputs voltage depending on that pressure. It's a simple pressure switch. Usually it's a 3-wire sensor, right? So we have voltage, signal, and ground. So if you were going to test this, you'll check for 5 volts, you'll check for ground, and you'll check for a signal coming out of it, making sure that the proper signal does come out of it based on the pressure. Now, it works very similar to like a map sensor, barrel sensor, that sort of thing. So very similar. The only problem is they're usually on top of the fuel tank. And where's the top of the fuel tank? It's usually pretty close to the body of the car. So sometimes, depending on the vehicle, you might have an access port, but other than that, you might not. So it could be hard to get to, hard to test. Right? So here's just an example on a Chevy Tahoe, right? 2016 Tahoe. And here's our 3-wire sensor. So the sensor signal, sensor low reference, and then sensor 5-volt reference. And that gives us the sensor itself. Or we could alternatively plug it in at a different connector a little bit further down the line if we can't get to that actual sensor. And then it tells us we hook up to the signal and the known good ground. So for a signal going back to the computer, key on, engine off, the voltage should be about 1.3 to 1.7 volts with no pressure or vacuum. So that's a static, nothing going on, just a atmospheric pressure. Remove the gas cap to make sure there's no pressure or vacuum. So that should equalize the system. Replace the fuel cap if we get a vacuum, like if we're purging, the voltage will increase. With pressure, the voltage will decrease. So the higher the pressure, the lower the voltage goes. The lower the pressure, the higher the voltage goes in this case. So that's fairly easy to test. You just look at the voltage. If I have it equalized, it should be somewhere in there. If it's not, if it's higher, if it's lower, then that indicates higher or lower pressure. Then we can cross-reference it with maybe a PID or something like that and see, is it a higher pressure or lower pressure, to see what's going on in that case. So leak detection devices. Now, speaking of leaks and pressure and all that, this is a picture of a vacuum pump leak detection assembly. So this has a multitude of things in it, and this is actually off a Subaru. It's off of my car, really. So this hooks up to the canister, and then it will draw a vacuum on the system in order to test it. So that's kind of like a self-test function. So let's read up a little bit about this out of our guided component test that's built right into the tool. So the leak detection pump and sensor are used as a pair to not only detect evaporative leaks, but also detect the size of the leak. The leak pump will draw a vacuum on the evaporative system. The pressure sensor will then monitor the system in the tank and look for any leaks. A drop in voltage would indicate a leak in the EVAP system. Leak detection pump is part of the vacuum pump module assembly, combining a vacuum pump with a drive motor, canister vent valve, and a pressure sensor. So my vent valve is part of this as well. So the ECM commands the vacuum pump to apply vacuum to the EVAP system during a self-test. To test either the canister vent valve or the pressure sensor, we'd go to the EVAP system selection in the guided component test to test those. Note, though, none of the internal components can be serviced separately. If any of them fail, the whole assembly, the whole module needs to be replaced. So if we look at the location of this is kind of interesting too. So the best test location is at the leak detection pump itself, because it's very easy to get to because it's behind the left rear seat under the cargo area and the steel guards. So I always remembered this back in school when they told us about this new system they were using. And it's not only behind the seat on a Forester, which is a wagon, it's behind the seat on just about all of them. And that includes sedans. So he said, well, just watch out for that person who's going to decide to screw in their subwoofers and amps in the back, and they're just going to drill in thinking it's okay. And well, they'll get into the steel and then they'll get right into the canister. So there's a fun EVAP leak right there. Good luck tracing that down if you didn't think about it or understand where the parts were. So it's underneath this steel plate. It's not that thick of steel though, so you could easily get a self-tapper through there and then right into the canister or right into the vacuum pump. So always got to be aware where things are on a car too, huh? That makes you think. But let's see, my pin assignment, right? So I got my canister vent valve control. So there's the vent control. 12 volts to the leak detection pump ground. 12 volts to the canister vent. 5-volt reference for the sensor, pressure sensor signal, and then the sensor ground. So we got the sensor here, canister vent there, and then the leak detection pump. So all in one piece. And also due to the internal circuitry of the leak detection pump assembly, motor resistance cannot be checked. So if we were trying to actually ohm out the motor, you can't because it's got like a little circuit board in there and it keeps you from getting to it. You'd have to take the whole thing apart to figure it out, right? If the DTC indicates concern with a leak detection pump and the powers, grounds, and wiring to the ECM are okay, you will need to replace the pump module assembly. So there really isn't necessarily a direct diagnostic. And even if you do find out that it's failed, it needs to be replaced regardless, because it's all in one, right? all one piece. Now here's another reference. This is on a 2016 Toyota Avalon. We're going to dig a little bit deeper into this car in a few minutes. But this case has an 8-pin connector, just like the Subaru one. There's a reason for that. They use pretty much the same system. But the location on this car is above the fuel tank. Fuel tank removal is necessary to service the canister and the components. So that sounds like it's very fun to get in there and test, because I got to drop the tank to get to it. So just always be aware, hey, these parts can be anywhere. On a Subaru, it's in the passenger compartment. On a Toyota, same system. underneath the floor, above the tank. Now, maybe that's to keep people from drilling through it, I suppose, right? But same type of system. So if you have a tool with guided component test built in it like this, well, then all that information's right there, right at your fingertips, right? So also is available from the manufacturer, right? So there's a reason that they would use this test, right? And you want to be able to force this test to happen as well. And we can do that with a scan tool, and I'm going to show you why. This monitor checks for the EVAP system leaks and canister pump module malfunctions. The monitor starts 5 hours after the engine switch is turned off. At least 5 hours are required for the fuel to cool down and stabilize the EVAP pressure, thus making the EVAP system monitor more accurate. So you might, it's happened to me, you might just walk outside one night and you just hear this random motor pump thing going. It's like, wow, what in the world is that? 5 hours after you turn the key off, it'll do an EVAP self-test. So it turns on, does its test after the timer's done. Now, the leak detection pump creates negative pressure in the EVAP system or vacuum, and the pressure is measured. Finally, the ECM monitors for leaks from the EVAP system and malfunctions in both the canister pump module and the purge vent solenoid valve based on the EVAP pressure. Now, here's an interesting hint. It's 5 hours. But if the engine coolant temperature is not less than 95 degrees 5 hours after the engine switch is turned off, it'll wait another 2 hours, so 7 hours. If it's still not less than 95 degrees 7 hours after the engine is switched off, the monitor check starts 2.5 hours after that. So 9.5 hours it could be after the key is off before this thing starts testing. So that's very important to know and understand, because if you're trying to get that EVAP monitor to run, you got to leave it overnight, pretty much, right? At that point, 9.5 hours, you got to leave it overnight. So if we go in here, this tells us our preconditions for the monitor as well. It will not run unless the vehicle was driven for 10 minutes or more. Fuel tank is less than 90% full. Altitude is less than 7,800 feet. So if you're in Denver, it's getting close. And if you're even higher than that, you might have a problem. Engine coolant temperature between 40 and 95. Intake temperature between 40 and 95. Vehicle is going to remain stationary, so it's off. Need to allow the engine to idle for at least 5 minutes and then turn the engine switch off and wait for 6 hours. So we need to wait an hour after the test happens in order for that monitor to be complete. So we got 6 hours on the 5 hour one, 8 hours on the 7, and 10.5 on the 9.5, right? Do not start the engine until checking monitor status. If the engine is started, the steps described above must be repeated. So if you start the engine to check, wipes it out if it hasn't been done already. So you want to make it sure. You want to be very, very sure that is the issue, right? All right, so now let's talk about a couple other manufacturers before we go live here. So here's the Chrysler eSIM. Mentioned that before. So that's EVAP System Integrity Module. That's there. And it's very similar to the NVLD they used to use. The design of the eSIM has been simplified so it does not require a solenoid. So the eSIM mounts directly to the canister, eliminating the need for a mounting bracket. It is critical that there's just another example of a canister that has parts directly mounted to it. It's critical the eSIM is mounted vertically. On vehicles where the canister is mounted on an angle, the eSIM requires an adapter to maintain a vertical position. When the eSIM is installed vertically, the electrical connector is in the 3 o'clock position. When the assembly consists of a housing, a small weight, and a large weight that serve as check valves, a diaphragm, a switch, and a cover. There's one large weight and one small weight check valve in the eSIM assembly. A seal is attached at the end of each weighted check valve. The large weight check valve seals for pressure. The small weight check valve seals for vacuum. The weighted check valves are contained within the eSIM housing. So that's why it needs to be mounted vertically, because of how these weights are oriented. It's attached to the EVAP canister, as we said, located under the vehicle on a mounting plate connected to the fuel tank. Best place to test it is at the connector. Also, depending on engine displacement, either 1 or 2 EVAP canisters may be used. Also, depending on vehicle model and fuel tank size, canisters may be mounted either vertically or horizontally. Skid plates may need to be removed. And then first, it's a test. So we have the signal wire and ground. So we're going to verify ground works. We're going to verify the signal gets back to the computer, and that's a fairly simple test. It's kind of a pass-fail as well. BMW, boy, that looks kind of similar to that eSIM module. All these manufacturers are using very similar types modules out there, but oftentimes we also need to use the scan tool to actuate them, right? So I'm going to take a look on this 2010 BMW 335i. there's a functional test for that inside there, right? So we have all these other functional tests we could do, but this one's EVAP, tank leakage diagnosis. So if we go in, we have theory and operation, a tank leak test itself, system actuators, and diagnosis and symptom tips. All right, so if we go in here, here's the theory and operation on the BMW. And it's an active state, filtered fresh air enters the EVAP system through the sprung open valve of the pump. When it activates the pump for leak testing, it first activates only the pump motor, pumps air through the restrictor orifice, so it has a pre-measured orifice, which causes the electric motor to draw a specific amperage value. So if it's got a 1 millimeter orifice or a 0.5 millimeter orifice, that the motor will draw a certain amount of amperage to get air through that size orifice. The value is equivalent to the size of the restriction. The solenoid valve is then energized, which seals the EVAP system and directs the pump output to pressurize the EVAP system. All right, so first it measures, and it says, okay, here's how many amps I need to draw through this metered size. Then it will detect it. So a large leak. EVAP system is detected as having a large leak if the amperage value is not realized. So if it doesn't get up to that amperage value that it measured on the preset orifice, so if it's the amperage is too low on the motor, then it knows that the leak is bigger than the size of the orifice. A small leak is detected if having a small leak of the same reference amperage is realized. So if it has a leak the size of the orifice, the amperage should be the same. And if it has no leak, the EVAP system is detected having no leak if the amperage is higher than the reference amperage. So if my amperage is higher trying to push that air, then it doesn't have a leak that it needs to worry about anyways. It may still have a teeny tiny leak, but it's not enough to cause an issue. The DC motor leak detection pump ensures accurate fuel system leak detection for leaks as small as 0.5 millimeter. Pump contains an integral DC motor, which is activated directly by the DME. DME monitors the pump motor operating current and measurement detecting leaks. So just like we talked about, it monitors that. All right. So that's one thing. And then diagnosis and tips on this as well. When manually pressurizing the fuel tank for leaks, false failures may occur due to the valve inside this module. Be sure to block this off prior to manually pressurizing. Check for leaks in the following areas: at the fuel tank level sensor, connections to carbon canister, plastic tubing, fuel filler pipe, and then the connector at the diagnostic module for tank leakage itself. A software error also may cause the engine light to illuminate for EVAP system failures in vehicles equipped with manual transmissions that are driven under the following conditions: low engine load, low RPM, low vehicle speed, etc. So it affects the following vehicles. If I had scrolled down, we could see more of what's going on there. So just be aware that sometimes it's just a simple flash can fix an EVAP problem as well. Crazy, right? So software error in the calibration may cause a mill for the EVAP system failure in vehicles equipped with manual transmissions. Crazy stuff, right? Crazy stuff. All right, so let's walk through, take a look at a few things on the tool that are pertinent to this as well. I do see a few questions coming through here. We got a couple chats there. We got quite a few chats up there. We'll get to those in a few minutes. So I have this 2016 Toyota Avalon. So that's the one with the vacuum pump that runs 5 hours after the key is off. So how would we go through that? So we can go into scanner and we go into engine. It's going to be in there. And then it is I think it's a functional test. No, it is not a functional test. It is a system test. I lied. So we go into system tests. We have an EVAP system check that's automatic and an EVAP system check that's manual. So the automatic's the way to go. It's just kind of let it go and do its thing. So it activates the purge valve, the vent valve, and the vacuum pump to draw and release vacuum to the system. Can be confirmed by observing the vapor pressure, right? So if you're here at the very, very beginning, I showed a video on how this would work on a real life car. To prevent damage to the system, the scan tool will automatically stop the vacuum pump when the pressure drops to below this. Refer to service manual for more information. Do not operate the vent valve and the vacuum pump continually for more than 15 minutes at a time, so we don't want to burn anything out. All right, make sure the vehicle's in park, ignition on, engine not running, fuel temp below 95. Fuel level must be between 0.5 and 9/10. And then if the fuel tank level is too low, the test will take longer to build the required vacuum and the test might fail. So just be aware of that. All right. And then I can't function through it because I'm not hooked up to a car, but it would work. It shows that, here's the steps that I'm doing. So the vent valve is open or the purge valve is open or both are closed, or here's the values on there. If you want to take a look at the quick tip video on that I showed earlier, you can definitely feel free to do that as well. So that allows us to do that. That forces the monitor, but if I do want to go into functional tests, I can see there should be a few things in here for that. So the vent solenoid valve, I can open and close that if I wanted to test the valve itself, or if I wanted to close the system in order to put smoke in there, right, for an EVAP test. I got to close the vent valve to do that, so we can turn that on and off, things of that nature to be able to seal that. All right, now let's take a look at some guided component tests as well. So I'll load my Avalon. So for those of you who don't know, if you have a Snap-on scan tool with a scope, it comes with guided component tests as well. There's over 5 million available guided component tests in there. And it doesn't just cover engine items like we're looking at today, but body, charging system, ADAS as well. So let's go into engine. And then we'll go in the EVAP system there. And then we have the leak detection pump information we just looked at, leak detection sensor, purge solenoid, system operation, vent solenoid, and a visual inspection tips in there as well. So leak detection pump just tells us how it works, right? We saw that. Pulls down a vacuum. Leak detection sensor, we have a couple tests we can do. So it should be a voltage test with a fuel filler cap remove. In this case, on this one, should be 3 to 3.6 volts, right? So it varies. The Chevy was lower. Let's see, system operation is going to tell us how it works, right? So it's going to go through the different checks. This is that automatic test we talked about. It's going to walk through those different tests as well. So a wealth of information on the tool, also a wealth of information in your manufacturer's information too. So let me get out of that. Let me check another car here. So we got that BMW in here somewhere. It's 2016. 2010. There it is. We got that BMW in there. So let's take a look at a couple things on the DMTL for this vehicle, right? So that's going to engine. And we'll just pick the first one, and it should be under functional tests, right? Special functions. And there it is right there. All right, so we have all these other special functions. There's our EVAP tank leakage diagnosis. And then we can go through the actual tank leak test as well. It's going to walk us through that. Cycling the ignition in previous steps is important. Make sure you cycle the ignition. Following conditions must be met. Battery voltage between 11.5 and 14.5 volts. Ambient temperature between 4.5 to 35.5 degrees Celsius, or 40 to 95. Key on, engine off. No faults stored, etc., etc. Make sure you have a battery charger hooked up, because it's going to take 20 to 30 minutes. And then if I hit yes, it would go and start that 20 to 30 minute test that we don't need to do right now, because you can't get out of it once you start it. So just be aware of that. All right. So multitude of ways that we can test these systems electrically. All right. We talked about leak testing. That was last week. We talked a bit about leak testing. You do want to make sure you close that vent valve though, in order to test for leaks. You're putting any smoke in there. Yeah, smoke machine is definitely key, but sometimes you really still can't find them too, because they're just somewhere in the middle there. So always good to look and check. And just as I said at the beginning, make sure you know, is it a leak or is it electrical, right? Because it's totally two different ways of testing it, if it's a leak or if it's an electrical problem. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.